In this video, we're going to be solving two-step equations similar to 2x plus 3 equals 9 using our algebra tiles. So in order to do this, we're going to start out with our t, just like before. And we're going to write our equation down, which would be 2x plus 3 equals 9. Alright, now I'm going to model 2. X, that's 2 x's, plus 3 equals 9. 3, 4, 5, 6, 7, 8, 9. Okay, now we need to get rid of this 3 over here. So in order to do that, I need to make 0 pairs. So I'm going to put 3 red tiles or 3 negative 1 tiles with those. And if I do that to one side, I also have to do it to the other side. Now, on the left-hand side, it's real easy to see I can take these 0 pairs away. Now, on the right-hand side, what's different is now I don't just have one color of tile. I have 2 colors. So my goal is to only have one color of tile on the right-hand side. So I have some red tiles and yellow tiles that represent positives and negatives, so I can make more 0 pairs. So let's pull these over, and this one over, and this one over, and that makes me 3 0 pairs, which I can now take away. And then I have 2 x's, not 1 x now. And so this tells me I need to divide all of these yellow tiles that are left into 2 groups. If I had 3 x's, I would divide them into 3 groups. So I can do that simply by sorting and go 1 in this group, 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 1 in this group. So then the value of x would be equivalent to what one group is. In other words, x is equal to, and these are yellow, so they represent positive, so they're positive 3. In other words, x is equal to 3. Now, if we check our work, we can do 2x plus 3 equals 9, and where there's an x, I can substitute in a 3. And one of the tricks that I use when I do substitution, before I put any number in, I replace the variable with a set of parentheses. This way I never have to wonder what I need to do, and I never have to wonder what to do with negative signs. So then I place in my 3, or substitute it in where x is, or put it inside that parentheses. And then I'm left with 2 times 3 equals 6, because I multiply first according to order of operations, plus 3 on the left-hand side. And then 6 plus 3 really is 9, so that 9 is the correct answer, and the value of x is 3. Now, if I use properties and actually perform a type of solution or develop an algorithm for solving that equation, I start out with 2x plus 3 equals 9. Now, the first thing I need to say is, okay, I have an x on the left-hand side, but I need to know what one of those x's is. So I need to move that positive 3 to the other side. I need to get rid of it. So in order to do that, I made 0 pairs up here when I did my manipulatives. And to do the 0 pairs, I added 3 negatives. So I'm going to do the same thing. And I can, whatever I do to one side, I have to do to the other. So when I add these two equations together, my 3 and negative 3 are 0, so I can mark those out. Now, on the left-hand side, I'm left with the 2x. On the right-hand side, I have a positive 9 and a negative 3. The signs are different, so I subtract. 9 minus 3 is 6. The big number is 9. It's positive, so that's a positive 6. And remember, it's understood, so I'm not going to put it there. Now, I have 2 times some number equal x, so I'm going to divide both sides by 2 because I want this 2 over 2 to cancel, because anything over itself is 1. In other words, 2 divided by 2 is 1. If that were a 3, I would divide everything by 3. Now notice, I'm not dividing by negative 2. Like up here, I use opposite signs. But down here, I use the same sign, because if I use different signs, for example, 2 divided by negative 2, that would equal negative 1, and that's not what I want. I want this to be 1x on the left-hand side. So I divide by 2, and what I do to one side, I have to do to the other. So on the left-hand side, I'm left with an x, and then on the right-hand side, 6 divided by 2 is 3. So my answer is exactly the same using either the manipulative or the algorithm.